All right, in this video, we're going to talk about, well, essentially rearranging formulas. These are what are called literal equations sometimes. And the reason we sometimes need to rearrange a formula is, say, for example, I have some formula where I take three numbers, L, P, and R, and I multiply them all together, and I output some M. So if I need to find M, I just plug these three numbers in and multiply them together, and I output M. But say, for example, I already know M, and I know L and P. I need to find R. Now, this would be difficult. I have to plug in M and plug in L and P, and then I have to kind of maybe do some guess and check or something like that. That could be really complicated. What I need to do is to rearrange the formula so that R is all by itself. It's isolated, and everything else is on the other side. So I'll show you how to do that. And this is really something you do with a lot of common like volume or area formulas and that type of thing. So let's take a look here. For this first one, let's say I wanted to solve this formula for L. So I'm solving for L, we'd call it, which means I want the L to be all by itself as opposed to the M. Well, if I have three things that are multiplied together and I want to eliminate some of them, I'm going to divide by those things. So I'm going to actually write this as a new line down here so that everything is LPR, and I'm going to divide by PR so that the P will cancel with P and the R cancels with the R, and I'll just be left with L all by itself. Of course, I have to do the same thing on both sides of the equation. So over here, I'd also have to also divide by P and by R. Okay. And then, in the end, I would just have M over PR, and that's P times R, we didn't put a multiplication symbol in between them, equals L. And the formula has been rearranged so that L is now all by itself. I can plug in M and P and R and output an L. Let's take a look at another one over here. Here, I think we wanted to solve for solve for N. So I want to rearrange this formula so that instead of plugging in N and P and outputting an M, I want to plug in an M and a P, and I want to output an N. So I need to get the N by itself. So first thing I'm going to do is get rid of this 3P over here. So I'll subtract 3P, subtract that whole term. Of course, I have to do the same thing on the other side, so I'll subtract 3P. Now these aren't like terms over here, so I just rewrite it as M minus 3P. And on the other side, we've got 2N still. Right? These two things cancel each other out. Choop, choop. Now, I don't want N, 2N, I'm sorry, I just want the N all by itself. So what I have to do next is divide by 2. And that way the 2 cancels with the 2, and I'll just be left with N. But I have to do the same thing on the other side. So all this would also have to be divided by 2. And so I'll just simply rewrite this down here. So M minus 3P over 2 equals N. And I could say, for example, if there were some simplification that could go on over here. So say, for example, if I had, coefficients of M and P that were even and they were divisible by 2, I could simplify or reduce that. But I can't here, so we'll just stop at this. So now I can input M and P into this formula, and I'll output an N. Let's take a look at one more, because this one down here is a really common one, actually. 5x plus 3y equals 19. This is a standard form of a linear equation. So all the xy pairs that make this equation true lie on a straight line in the graph. But oftentimes, we want to have the y all by itself so that we can graph it, and that's called slope-intercept form. So we're changing from what's called standard form, where the x and y are on the same side of the equal sign, into slope-intercept form, where the y is isolated, and they're easier to graph that. So, if we want the y all by itself, then the first thing we need to do is get rid of this 5x. Right? And of course, you have to do the same thing on the other side. And 19 and 5x, those are not like terms, so I can't just subtract them. So over here, 5x and negative 5x, they cancel each other out. I'm left with 3y. And over here, I just put 19 minus 5x. Now I don't want 3y over here, I just want the y all by itself. So I will just divide by 3 so that the two 3's cancel. And then on this side, we'll have all this stuff over 3. So now I have y equals 19 minus 5x over 3. And one last thing I'm going to do is, this isn't really super necessary for this problem, but if I wanted to imagine this was a line in slope-intercept form and I wanted to graph it, it's not quite in slope-intercept form. So what I would have to do is to split this fraction apart. So the y equals stays the same. And I have 19 over 3 minus, so the minus goes down here, 5x over 3. So if I have the difference of two things or the sum of two things and they're all divided by some single number, I can split that fraction into 2. So I have 19 thirds and I have negative 5x over 3. And then, kind of running out of space here, so I'm going to move up here, I would just kind of reverse the order. Y equals negative 5x over 3 plus 19 over 3. So I'm just switching the two around, which is okay, making sure your negative stays with the 5x over 3. And then finally, and you wouldn't have to break this down to this many tiny steps if you're doing it yourself, this becomes negative 5/3 x. So 5x over 3 is the same as 5/3 x, same thing, plus 19 over 3. So now I have it in that mx plus b form, which is like a little bit extra. If you just had to solve for y, you'd be done here. But if you really wanted it in that mx plus b form so that you could easily graph the line, I know that my y-intercept is 19 thirds, which is kind of an ugly number, and my slope is negative 5/3. Okay. So just to review, anytime you want to, if you have things that are multiplied together and you want to eliminate some of them, then you just divide, make a fraction out of it so that they cancel. If, on the other hand, you're trying to eliminate an entire term, then you would subtract. Or, I suppose, if it was negative, you would add. You just cancel it out by adding or subtracting. All right.